Thank you, Jeff and Johannes, for a couple of extra minutes. I'm going to need them. So I am Arseniy Zaostrovnykh. I work for Sonar, where we analyze user code statically with Clang technology. And today, I will talk about the reporting for those advanced bugs, the path-sensitive bugs. And to be clear, the path here refers to the execution path and not the file system path. Most of you probably heard about the boy who cried wolf. It didn't end well for him, and we have a similar problem in static analysis. Especially for advanced static analysis, we quite often have false positives, the bugs that don't really exist. And if we have them too often, then people will just stop paying attention and might miss real bugs. So this creates a vicious circle with initially low trust in the analyzer that leads to low attention that people pay to the findings. And since those findings are pretty complicated, usually by nature, they are often misunderstood with this little attention, so they are following the common bias: if I don't understand it, it must be wrong. They are misattributed to be false positives and decrease the trust in the analyzer further. Now, of course, we could, and we do, increase the precision of the analyzer, decrease the number of false positives. That's very important, but that's not enough. We also need to improve the clarity of the reports, understandability, because even a true positive, the real bug that's reported that is not understood, is as good as a false one. So if we have clearer reports, we'll have more of them understood by the user within the same attention budget, and more of them hopefully fixed, so the analyzer will be regarded higher. So in this talk, I will describe the role of interactivity in producing the reports about existing bugs that are both comprehensive and comprehensible, so they don't overwhelm the user. Let's look at the issues ranging by complexity of how they are reported. And in the following slides, please don't try to read the walls of text. They're just for the illustration purpose. We start with simple issues that require just one source location to highlight. And for this example that is riddled with issues, if you run Clang tidy on it, you will see them all right in your face. And to be fair, each of them is pretty well written and understandable, but it's still overwhelming overall because you get them all at once. And the text-only output doesn't really let the analyzer much of flexibility here. And I argue that in the GUI, this same list of issues is more manageable because you can list them, you can sort them, you can filter them, you can focus on the issue you're interested in, and see more context without being overwhelmed. If this point is not clear for the simple issues, let's look at the more involved ones, the issues that require multiple source locations to understand. So this is a typical error where the compiler gives you the whole overload set, and sure enough, one of those constructors is the one you meant, but all the others essentially are irrelevant, and so it doesn't really help. In the GUI, you can manage the multiple source locations better because, multiple secondary locations, because you can focus on the issue you are interested in, display only those secondary locations, and also have them in the list, so you can focus on the one you're interested in and see more context about that. Now let's go to the most complex bugs that require a lot of context to understand. Here, the analyzer would typically give you a flow that walks you step by step through the execution that might reproduce this bug. And you are maybe more familiar with the UI that Clang Static Analyzer has out of the box with the HTML output. This is pretty good, and this is arguably an improvement over the command line analog of that, where you have the same information printed in text and with all the source citations interleaved. Still, it falls short for quite a lot of issues that I don't know what happened here with the PDF. Yeah, well, that's a flow of 39 locations, and that was supposed to be in the left upper corner. Anyhow, so we have some long flows produced, and that happens pretty often, and you have to look through this long flow, and you spend a lot of time to understand what's going on, and often this is a false positive that's a frustrating experience, and next time you probably won't even want to look into that. In particular, here, apparently the anti-def buffer could be null when we call this function on the line to 269. And to understand that, you have to walk through this flow. This step that is apparently marked as 11, but it was step 6 originally, is the critical for the understanding. It says that the trailing variable is assumed to be null, but there is absolutely no information in the flow what the trailing variable has to do with the anti-def buffer. And that shows that whatever the flow, even if it's so long, it might still miss important details. And this is not surprising, because if you want to show everything that is related to the anti-def buffer to the issue at hand, you would end up with a data flow graph looking like this. And with a single flow, the only choice you have is to traverse it sequentially. And that makes as much sense as reading the Choose Your Own Adventure book. You are supposed to choose the action that happens next and then navigate numbered paragraphs. If you read it from beginning to the end sequentially, it will make absolutely no sense. So let's apply the same for the reports of the issues. That is what we're experimenting with at Sonar, and we have some interesting results. We take the same data flow graph, and okay, here it also broke a little bit. In that data flow graph, we show these nodes piece by piece, and show only the relevant values for the current node that you're exploring. So here, the anti-def buffer might be null, so this is the relevant value. And we can click on it and see what is relevant to that. The anti-def object itself is relevant, that's for one, and the anti-def buffer is the field of that object that is probably more relevant, so let's explore that. Here you can see that anti-def buffer field was invalidated. That's this third block on the left. And that is very important information. That means it escaped as an L-value reference to an opaque function, and so the analyzer essentially reset what it knows about it. And then you can follow some other related values to that, but most importantly is the assumption that's made about this freshly generated anti-def buffer symbol. So you can see the trailing node that gives us the assumption that anti-def buffer might be null. So let's look at that and see how it is related. This time we can see that it is actually aliasing. So it was a couple of lines above, it was initialized to anti-def buffer plus some constant, and that means it is aliasing, and if it is checked for nullability, that means the anti-def buffer might be null as well. And so here you have it. The conclusion is that this anti-def buffer was invalidated through an opaque function call. It was escaped, and then it was aliased with trailing that was checked for nullability. So analyzer assumes that the anti-def buffer might be null as well. Now, for the reporting, that's the job is done. So it's not about truth telling, it's about explaining what the analyzer assumes and the reasons for that. And if this assumption doesn't make sense, that's for the user to decide. So to understand the issue, we explored just 7 nodes of this huge data flow graph. Unfortunately, it's usually impossible, or at least very hard, to predict which 7 nodes would illuminate the user. So the analyzer either skips some of the details and risks them to skip the relevant and important details, or it has to print a lot of information that potentially is just noise. So I've demonstrated how the interactivity enables clearer reporting without losing too much context. And that is just scratching the surface of what the GUI enables us to do. And all that for the sake of understandable reports that are paramount for static analysis, just like the precision itself. Thank you.